shape, or form. Now I'm thrilled to announce Tony UV, who I've known for years. He's a longtime contributor and OWASP member. He's going to be talking about building valid threat libraries for cloud-based applications. So let's give it up for Tony.
All right, mic check. All right, cool. Hey everybody, thanks and welcome for welcoming me to London, and pleasure to be here. Sorry that we started a little bit late. Dive right into things. I want to go ahead and just cover what the objectives are of this talk. The main thing is that, this talk is kind of multifaceted and there's really too much to cover within 45 minutes. What I try to do is basically build a case study tailored towards the energy sector, oil and gas specifically, where cloud adoption is now resurging for various business reasons. And so I thought it'd be an opportune time to talk about, exploring some of the threat, building a threat library for that sector, as well as seeing how building a threat library can actually help facilitate automation in DevSecOps. So, obviously that's a lot to cover right there. I mean, just the case study alone is enough, is a mouthful. What we're going to try to do here is to exemplify a threat library and basically show how we can build some context into the application, into a cloud application that I basically am using as a guinea pig. It's actually a real application for a multinational company that is one of the largest producers of oil and research and exporters of oil in the world. Secondary goal here is that, I want to demonstrate the main point here is that a true threat library can actually help to be the cornerstone to marrying that to attacks, vulnerabilities. There's attack libraries that exist, like KPEC, and vulnerabilities and weaknesses that exist, lists that exist. Obviously CVEs in the hundreds of thousands, CWEs in the hundreds and growing. And obviously your affected components of an attack surface. So the idea here is that with a threat library, if you're in DevSecOps and you're like me and you want to do some automation because you're tired of this kind of stagnant security industry going nowhere, you want to be able to facilitate a lot of the things, and the threat context provides multiple different benefits. We'll get into that in a second. Lastly, looking at this diagram here of DevSecOps, there's things that are happening when you're planning and you're coding and you're building, et cetera, and you're doing all the operational and development activities. There's opportunities for you from a security context to understand what sort of security inputs do you need to go into this process. And with today's CSPs, cloud service providers, and their related products, there's a multitude of different web-enabled interfaces that you can query and that you can actually set settings for in your respective cloud application. A little bit about myself. I'm not going to bore you with a lot of details other than the things that you see here, but the reason I really show this, and by the way, my contact information is there mostly for feedback. I'm really interested for your feedback, things that you would like to see further evolved in this talk. It's just 45 minutes. We'll love to make this a 2-hour thing and just kind of add more to it. But, I've done a lot of things over 25 years, and the benefit of starting out in IT is understanding process and understanding different systems, different types of workflows, both within multinational companies and startups. I'll just use one of the things that's not on here is that actually was one of the first speakers at the SCAP conference in Baltimore. And SCAP, for those of you that don't know it, I'll talk about that at the end, is a security content automation protocol. It was a wishful thinking for some level of security automation that never really happened, and there's different causal factors for that. But here in 2018, here we are, and for me, I want to kind of highlight one of the biggest things with the smiley face is that I would love to bankrupt our own industry with some automation. Just so that we can move on to some bigger and better things. And I think it's timely. I think we can do it, and I think that we'll soon get there. But before we dive into threat libraries, I want to clear the air a little bit on some threat considerations and misinterpretations. I have some quotes up here that I think are pretty good takeaways. If you get a copy of this deck, I think that they're pretty good words to live by in terms of applying threat libraries or threat modeling to cloud. So let me start with a problem statement. And some of this that I might say might be heretical. Again, we're talking about threat libraries. Obviously, threat libraries feed threat models specific to cloud. But there's some clarifications that we need to do when we talk about threat modeling activities. There's this notion that oftentimes that vulnerabilities, equal threats, and that actually a data flow diagram is in and of itself a threat model. And that's absolutely incorrect. There are artifacts that support a threat model, but they're not in and of itself the entirety of one. The reason I bring this up is because there's a lack of understanding in terms of what is a threat. And the simplest way to really define it, and really in any English dictionary that you wish to use, is one that is a possible of a menace, right? You sometimes hear in the weather that says, the storm, the sky is threatening with showers today. There's always this underlying theme of like a possibility. Versus attack, it's something that actually happened. Today in Baghdad, there was missiles that came in, so-and-so city was attacked or whatever. There is an absoluteness to an attack. And so this is important when you're building a threat library, is to be able to understand where you're going to get your information. Where are you going to harvest your threat intel from the outside, right? Who are you going to listen to for outside intelligence that's really threat? And how are you going to harvest your own data? AWS and Azure both provide, a centralized dashboard of security threats. I just looked at the new Azure security dashboard, now called Hybrid, and it has a lot of bells and whistles. It has a lot of automation and workflow capabilities, and it has a threat component as well. Buyer beware with a lot of the threat plugins that is in your CSP, your favorite CSP dashboard or whatnot, because a lot of the threat intel that's going in there is being fed by security vendors. And not to really basically dismiss a lot of the security vendors that are out there, but again, they're providing some of these formulas that really violate the definition of a threat. So a proposed resolution is that while you're considering and building a threat library for your cloud application, consider some of the following. Sometimes that the industry threat perspective, like we're going to talk about oil and gas, we're going to talk about energy. There's a lot of experts in that field. There's been crimes that predate information security. So that's a competitive market. You're talking about millions of dollars a day. So there's more than enough incentive to do fraudulent or competitive behavior. So you begin there. Begin with the industry experts to understand the field. The secondary thing is if you're building let's say we're all building a cloud application for a refinery or a company that is doing R&D for new development of oil wells. You want to be able to mine a lot of data, right? Because the future of the energy sector, and the reason that energy is really going to the cloud, is to mine that data so they don't have engineers having to carry around laptops and interface with sensors and PLCs and stuff like that in order to get data and then aggregate it somewhere else. The automation is basically beckoning major players from Shell, Exxon, et cetera, to be able to go to the cloud and use the computational power there. The other thing too is, for this exercise, a security champion conducting threat modeling. At the very end of this talk, I will give a kind of a psychological profile of the ideal individual to really aggregate different key facets to really pull together what is good threat intel from the outside and what is good threat data that your cloud platforms and your own applications are actually harvesting if you're doing the proper level of logging. All right, so further clarifying on terms, I just want to be able to say, this castle being depicted, threat modeling is a model of threats. I'm always interested to see, that threat modeling gets so convoluted into complex definitions. It's a model of threats, as the name implies, and it predates all of our industry roots. It's always been a model of threats. And so what we're doing here today is trying to model the full cloud stack. You have cloud management APIs that affect the security of your infrastructure, IAM policies, access control policies, ACLs at the network level, architecture, DNS. All those things are beyond your VMs and so forth. So unlike other types of threat modeling approaches, we have to really consider the full stack. I already talked about some of this other stuff here. Threats are often inferred from attack surfaces. And security professionals sometimes like to do this where they basically let the asset, the information asset or the technical asset be their reason for applying a threat. without actually understanding a threat motive and a threat actor and so forth. The main point here is that fourth bullet point that is going to be kind of a theme to this whole talk is how can we take a threat library and correlate it to a good attack pattern to exemplify viability of attacks against a cloud application. That's going to be, I have actually some personal experience in federal in the United States with this, where I've worked a lot with MITRE over the years. The guys there have done CVE and attack now with the post-exploitation framework and whatnot. And what's great about some of the things that came out of Styx and Taxi that's now adopted by OASIS and not MITRE anymore is the fact that there was a schema, right, that had indicators of compromise and threat campaigns and stuff like that. But what was missing from that great schema was the ability to marry that to a KPEG or to a CVE. Over the year, since OASIS took over, what happened is that the KPEG identifier got deprecated. And so you basically have, this Styx and Taxi protocol to be able to share threat intel, right, in a standardized fashion, to be able to create, some resounding threat evidence, but you couldn't really marry it back to your attacks that you wanted to maybe exercise in your automation and as terms of security testing. These are all things that are extremely important, and this is why my colleague of mine in OWASP developed the PASTA framework many years ago, and we're only going to talk about really a tiny fragment of stage 4. This is the PASTA framework. It's a linear process meant to be collaborative amongst architects and developers, and we're going to talk about how the threat analysis is really one of the key cornerstones to a great threat model. Now, one of the things that I took this actually from the book. In the book, I talk about different maturity levels when you're doing threat modeling. We're going to focus on an intermediary step of evidence-driven threat models. The goal here for us is to build a threat library that's supported by evidence, supported by actual, socioeconomic evidence, evidence within the field and industry that we'll cover of the energy sector, evidence provided by vulnerability data, threat actors, et cetera. Again, this particular model is interesting because in 2015, we published the book with Wiley Life Sciences. And in 2016, 6 months later, this particular research came out, and it was interesting, and I won't get all into the details. You guys can read this on your own. I want you to focus your attention on, this was really covering, this was from Carnegie Mellon, and they were doing coverage on different TMMs, threat modeling methodologies, and they cover this persona non grata. I don't know why, okay. So the persona non grata basically says, listen, let's have more of an attacker-centric model for threat modeling. And that's exactly what PASTA is. It's the process for attack simulation. Let's get into a criminal mindset. Let's not be security professionals. Black hat is too soft of a word. Let's actually truly try to emulate the threat motives, the actual means and ways and techniques across the full stack, including human vectors, for hitting our targets. And so what was interesting with this research that was done is that the PNG model basically had the least false positives, and it basically had the most consistent threats identified across multiple teams using different methodologies. So, this is interesting because it's basically supports a PASTA framework for a risk-centric approach. It's linear, that's evidence-driven, it's attacker simulation. This racing model is just simply trying to depict all the different cross-section of people that could be involved. But let's close this out by basically, taking away some key points as we wrap up this first section to this presentation, is learn to substantiate your model. FUD perceptions do not constitute valid threat patterns. It's important to contextualize your abuse of your cloud applications with the right threat intel. And let me just say, oftentimes in security conferences, there's always a talk about problems messaging vertically up. As security professionals, we can message fairly well horizontally with other engineers or with maybe a CISO or a security champion, but understanding threats is a universal piece of information that messages really well. and it could substantiate so many different things. Funding, legitimacy for remediation, even from the naysayers that we commonly face within our environments. So the role of the threat library is intended to provide a living body of content around viable threats. And with DevSecOps, we have the opportunity now to feed that threat library consistently with more alerting. So if you think about, in the monitor and operational phase of our DevSecOps lifecycle that we showed before, there's events that are happening within our system, our application, our frameworks that we're using, and we want to log those things. Now, that's a lot of information. And the key thing is what to log and marrying that back into a threat library. Just to close this out, this section now, here's an example. I was looking at CSO. CSO, I enjoy their articles. They have, the Dirty Dozen, 12 top cloud security threats. I took a look at this because I was like, wow, maybe they'll talk about some of the things that I'm already finding here. But, as I saw, the article basically just showed a lot of vulnerability or post-incident related information. It's really not threats. And so why is that important? Because the threat messaging, first of all, the threat piece of information will correlate to an attack pattern. So data breaches is too broad. Insufficient identity, credential, and access management, that's a vulnerability. Insecure interfaces and application programming interfaces, that's a vulnerability. This goes back to what I opened up with, that inferring that a vulnerability automatically applies an automatic threat is logically erroneous. It doesn't even marry to our non-technical areas of our lives, if you apply this on a personal level. So the reason that I bring this up is so that we can basically build a better threat library, and we're going to explore this now in looking at threat modeling with some integration with DevOps in the energy sector. So let's build some background to what we're looking at here. So the energy sector is riddled with a lot of players, and increasingly so. Obviously dwindling resources. The exploration for gas and oil has been happening for decades. So there's a competitive market for first to market on finding new sources of crude oil. Traditional threats have encompassed piracy, pirates stealing, wrecking ships and attacking ships for their oil. Terrorism, insurgency, organized crime, civil protests. So right there, we're legitimizing. Before we get into the cyber aspect of things, before we get into interconnected, web-enabled PLCs and SCADA systems and ICS controllers and stuff like that, we already have motive. We already have crime in the making for years. And so there's definitely motive and there's means. Now, with the facility of web-enabled protocols and cloud service providers, we have some opportunities. Again, let's take on the adversarial approach and not the white hat approach right now. Let's think about how we can benefit from some levels of sabotage or data tainting, and we'll get into some of that in a second. So it's a highly competitive, capital-intensive industry. Some of in building a small, this is just a subset of the threat library that we'll look at, but the reason that a lot of these energy providers are going into the cloud today is because of the massive amounts of information that all of their operations is doing. From the R&D aspect to the well refineries to finding new downspouts and performance of their equipment, all that is data. And now they're eager to get to the cloud. So what I did is I found a good guinea pig. Statoil is any Norwegian in the room?
Statoil stockholder, is that close enough?
That makes you Norwegian in my book. So Statoil, now is Equinor, and so basically they teamed up with a company that basically developed a cloud. So the far left one basically, so Statoil's trouble-free move to the cloud. That company there, Subsea, I don't know if you guys can see that, they basically are a Swedish company, and they developed a platform for managing well spots. Now, for managing wellheads. The application's name is WellSpot, and basically it runs in Azure. Okay, so basically they provide this multi-tenant login, FlexTrack multi-tenant energy app is that in the middle, and you just put in really the domain, and basically it allows you to look at what different forms of authentication in that far right that you can basically try to kind of highlight it there a little bit higher. But there's multiple forms of authentication: integrated authentication with Active Directory, Azure AD, YubiKey, SMS even. And so, when let's stop to think about a little bit about what could be our threat motives. So Statoil, if you know a little bit about them, they have been declining in their fines for good crude oil, but their actual production has increased, which just makes them a lot more efficient for what they have. But they're relying on data now. They're relying on data in order to see how well they're doing and performing. They're also a public company, as my man over here has noted that he bought some stock. Let's look at what I like. This is a threat model card that I like to give certain clients for an application or even an organization. One of the things that I like to do oftentimes with my team is organizational threat models, but we won't get into that. But if you look at the threat library here that's established, you'll notice that it's pretty small. A threat library should be pretty manageable, and it should denote some level of menace to a target for some level of profit. There are some things that are basically italicized because it doesn't matter if you're in e-commerce, if you're a nonprofit, if you're a church organization, if you're higher education, you're going to face some of these threats, right? Cryptojacking now is the new formal term. The extortion, is a gold mine in any field. So you have some consistent threats that should be part of every threat library. But then you have some things that are related to things like sabotage. Where sabotage could be sanctioned by corporate adversaries that basically want to be able to throw you off your data mining game for competitive advantages. Tainting data being reported back can happen in multiple different ways, and basically it affects the accuracy in reporting. There was a number that was pretty astonishing that Statoil shared in an article that related to an amount of $750,000 a day is basically lost if there's inaccuracies in some of the data inconsistencies that they have in the field. And if you look at we're not talking about all the different aspects of oil and gas, but just in managing their well spots. We have an enormous amount of equipment that is tied together and interfacing now to this platform. So a lot of the data of how their sensors are performing, how much metrics or crude is actually being discovered, the type and the quality, all of these things are being reported back. And like I said before, there's some incentive for hijacking a lot of that data. The main theme, if you think about a CIA triad, it's not confidentiality, obviously, it's the integrity and it's also the availability. Being down or having poor data will completely cost a company hundreds of thousands, if not millions of dollars over a short period of time. What I've done here is I've established a threat library based upon a lot of the research that I did, and I'll get to the research sources towards the end of the talk, but I married it to an attack surface of what I know of the application just from completely an OSINT model, and also attack patterns that would basically undermine those attack surface components. And the associated threat matrix there is really intended to show where my threats are correlating to my attacks and to what components in my attack surface. Now, where this gets interesting for DevSecOps is when we build out attack trees. And just in looking at one parent threat node, we look at the threat from the threat library of sabotage. This one is related to an operational activity of flaring alarm data. So maybe I want to sabotage and basically trigger some alarm systems alarming in order to stop production. There's obviously, you can imagine there's a lot of regulatory and safety measures that have to be abided by. So when things alarm, stop production affects production and availability. So I can't see this as good as you guys can see it, but and I won't go through all the different branches here, but I like attack trees because they're visual. I also like attack trees because it shows the relationship between the parent node of a threat and the underlying attacks, and it could be a one-to-many relationship. Now, let's start to think like a pen tester now. Let's start to think about automation and testing. Anytime we have an attack pattern, we can maybe cross-reference it to a part in MITRE's attack library, KPEC. And we can start to feed our testing engine with these types of KPEC values, which are correlated to payloads. There's a great open source tool that we've been using for a long time called vFeed. Anyone use vFeed here? No? Basically what it does is it basically takes all of your CVEs, it doesn't do it for CWEs yet, and it marries it automatically to your KPECs. And if CVEs, they're literally like 700,000, I think. And then with the KPECs, I think it's just a couple hundred. And so you have a one-to-many relationship, but going through and doing searches, like I did, in order to basically build this tree is not automated. This is not where the DevSecOps part comes in. But if you have something, if you basically have a threat library, if you build a threat model with a threat library and it automatically can correlate to KPECs, you can start to have testing to the areas of your application that are most critical. Going back to the threat card here, the idea is that when you sit down with product managers, project managers, senior management, they're going to get that. They're going to get that. They're not going to get KPEC. They're not going to get CVEs. They're not going to get the CERT reports. They're going to be like, your 10 seconds of being in my face is over. But this makes sense. And when you can marry that all the way down to say, do you want this to happen? We found that we have evidence from energy sector research groups, operational groups. There's some research that I pulled from the European Council, which had a special energy cybersecurity report. I also pulled evidence from the Department of Energy in the United States. They had their own security report. And all of these things substantiate the threat library. But as we go into the attack tree, we marry these KPECs, and I didn't do it for all of them, but I did do it for the vulnerabilities and weaknesses, is that you have now things to check. I wish I could, I'm tempted to fast forward to one of the dashboards from Microsoft's really cool Azure hybrid platform, because there in the top right it says 24 million alerts. I think anybody that's been in operations, and I've been in security operations in the dungeon, eyes on glass, looking at alerts. Now we got SIMs and IDS, different types of things feeding, feeding something else that feeds something else that feeds something else, and we have a content problem. So the idea behind a threat library within a threat model is to provide some level of poignant security focus, so that you can test the things that are most concerning. It doesn't mean that you forego the rest of the things, but you begin by addressing the vulnerabilities that really affect the attacks that make that threat actually viable. The other thing too, before I close out this graph, is the last kind of area here. So these vulnerabilities are affecting components, right? So these are components. It could be server-side components. It could be frameworks. It could be third-party libraries. Whatever is really in scope. But the good thing about it here is you have this last rung of what every developer wants to know. I was like, fine, I'm tired of you scaring me. Now tell me what to do about it. And so all of these different, I put D for defense mechanisms, really countermeasures, is intended so that you could actually, these marry to parameters and API checks in Azure. All of these do. So there's a way to automatically, query the Azure interface You could also use the Azure agent if you're looking at a VM, but if you're looking at, network rules or policies or privileges, you can query all these things to see if you actually have a problem, or you can actually do a HTTP put, in order to basically post a control that basically mitigates the attack patterns in the tree. When I was, one of the cool things that I think would be great, and if anyone wants to join me on this crazy mission, I would love it, is to can you imagine if we have like a threat model schema standardized, there's a standard schema, it can basically marry to sticks. We basically we can pull threat intel from taxi services around the world. There's only like really 30 credible ones. And you can basically take that threat information to reinvigorate your threat model, but we need a schema. And I've been talking about that for a long time, and usually people ignore me, but one day. I'm just going to show a couple of different, script mapping countermeasures that can be automatically implemented. I only got a few minutes left, but there was a vulnerability in my attack tree related to an exposed Redis cache server. So, Redis caching system exposed erroneously. I'm trying to validate. So this is more of a detective control that I can do maybe during my during my build process, right? So in my DevOps process, maybe I want to be able to validate and say that, okay, I actually have my Redis server configuration actually not exposed to the internet. This is basically what the JSON actually looks like. You get basically a 200, if everything checks out okay. But what it's doing here is providing, if it was completely exposed, you would have a start and end IP that would be null. But here we're basically assuring that there's a whitelist of IPs that can only get to it, which would be the inverse of what we have in our tree. Now, from a preventative check, where we're actually wanting to change this up and do a put, we can basically we can change the configuration if we don't have this control enabled based upon our attack tree, based upon our threat model, and we can basically say, well, we have this exposure, architecturally, let's go ahead and close that gap. AWS is no different. You guys might be definitely, I'm sure, using AWS. The problem with AWS compared to Azure, in my opinion, is that the security products don't converge into one management, dashboard as neatly. I mean, you have all these different fractured. Guard duty is great. You have, the firewall manager. You have the AWS WAF, but Azure has this pretty cool all-in-one, all security in one place. It's really cool. This is what I was talking about before. You have that 21.4 million, alerts, and so this is what I'm trying to kind of convey here. The traditional approach, and we're getting automation through cloud, right? We're getting web-enabled APIs that support JSON and other structured data in order to share information. That's great, sharing information, but that is an expletive amount of information, right? That is non-operational. That is non-operational. But so the idea, if you overlay this great information, there's a lot of good information. This shows most attack resources. This has SEV levels. Nothing out of this world. But if you overlay what you have here and you build workflows, which you can, then you can also customize your alerting based upon what assets, what's in your attack surface, or you can customize alerting based upon certain types of vulnerabilities that you find. So, the focus versus traditional approach is simply trying to mitigate the things that matter faster. For the energy sector, in this example with that Swedish company, the other concern here is that this SaaS provider, they're really a SaaS provider for Statoil, and they're, what makes, if we were all, Statoil, what are we to think that they're doing a threat model-based approach, or even looking at this for our application? And that's the scary part, and that provides another element of concern. There is the vendor risk aspect, right? Is the consideration is any of these alerts, because that dashboard is per tenant. So this only applies to Statoil, but if Statoil doesn't really have any insight to this, and it's only managed by the third party, then you're going to have a loss of any sort of knowledge in terms of what are the types of alerts that you're actually seeing that are affecting your threat model. I'm going to close out and just simply say the future of your threat library and security automation, requires kind of a schizophrenic type of personality in security. I enjoy playing that role often. You really kind of have to be a mashup of these, these individuals. You have the founders of Unix on one end, really understanding technology. There's a lot of security professionals that, don't understand enough about emerging technologies, emerging frameworks. So that's crucial. Being able to think like a criminal is probably even more important. I think that's a deficit. It's important to think and understand what are the nefarious motives, and most important, what are the economic benefits of that nefarious motive? We're not talking about script kiddie stuff. We're talking about true operational hacking that gets us paid, where we can establish persistence, where we can basically pass the hash and harvest credentials and compromise IPs and sell them and work for nation states that are sanctioning all this stuff. And the last part is the global economic business hat. I put my friend there, Warren Buffett, so that we can basically have, like going back to the oil industry, do we understand enough? I think I put on here is that the business perspective really addresses the business threats and not necessarily the security threats. And oftentimes when we want to look at threats, especially in the cloud, we think about security threats. But we don't basically take the time to understand the threats to the business, which is where our threat model should begin from a risk-centric standpoint. These are some of the threat libraries that I found very useful. I did want to cover the transportation sector, but this was way too short of a talk in order to do that. But there's a couple of great resources there. There's a lot of these ISACs. I give most of the ISACs a C- except for the financial one. Most of them really don't have a good information of indicators of compromise. When working with the FBI, as an example, or the local state bureau of investigations or Secret Service in the United States, most of the time they don't care about what's happening with you and your organization. They just want to solve their cases. So if you have information to help their cases, then they'll share information. So the ISACs I gave about a C-. The industry sector reports are extremely good. Sometimes I would remember I was in Eastern Europe one time, and I was trying to get intel for a socially depressed area, economic recessed area in that part of the world, and how that can correlate to different types of cybercrime. And I got some really good evidence from state officials, Interpol reports and stuff like that. So they're not that as hard as you might think to get. You just simply have to have the right connections, but they're an A+ definitely in terms of having really good threat intel. Now, comparatively speaking, there's companies that advertise threat intels to build your threat library, but the best ones is if you can basically do these 4 things. Twitter, Google, phenomenal. I mean, if you can build your own bot using Slack and Teams and different, even simple RSS feeds, I found those to be even sometimes more helpful than some of the OTX feeds that, for example, Alien Vault sometimes shares, not to discredit some of the things that they're doing. Also, industry leaders like GE and Data Command, they speak at length about their devices in the energy sector. They talk about, and if someone that is not in the energy sector, I want to know, how does your sensor work? I want to know what protocols does it use? I want to know if it uses IoT protocols. Does it use, what non-standard ports is it using? What non-standard, calls is it using? How are they falling into my CRUD model, create, read, update, delete? If I have information about the manufacturer or OEM details about their systems and understand their use cases, I'll be in a better position to build a real threat model. Lastly, this is my last slide here. Looking forward, a lot of people look to organizations like MITRE, and I'll go back to my story where I was one of the first speakers talking about the SCAP conference in Baltimore. And SCAP is still around. It's still 1.3 or something like that. And this is going back, almost 10 years. So 1.3, 10 years. So my My thing to you is don't hold your breath for security automation to come at the hands of some sort of, standard body. We are the ones, maybe through the conduit of OWASP and other organizations like it, to create that level of ingenuity where we can create the right schema, where we can create maybe like a body of threat vignettes that, retail, e-commerce, higher education, government, in different facets of our businesses around the world can actually use and benefit. Ultimately, there is an enormous opportunity. I mean, even right now, with some of the examples I showed with Azure and the exposed APIs, they have reference sheets for showing what is exposed, what parameters does it need in terms of post, get, put requests, that you need to pass it in order so that you can check whether or not that control exists within your cloud application. So the ability to do some of the things that I've done as part of this presentation, which didn't take a lot of time, is something that everyone can really do for their own respective cloud applications. If you do have any further questions, or if you have some ideas that were triggered from this talk, would love to talk to you afterwards, or you can hit me up at any one of these mediums. So appreciate your time, and thanks for having me.